Hello, it's Peter and
Darek.
welcome to the third episode of Distributed .NET Core. And before we begin, just a quick note, because in the latest episode we forgot to put there one thing. As you might remember, I added here this initializer for MongoDB, and in order to use it or any other initializer, for example, to initialize the data when your application starts or some database conventions, there is one thing you need to do. Simply inject here startup initializer interface, which goes like this. Let's say initializer, and just call somewhere initialize async, and that's it. Okay. So let's get back into our main topic for today. So today we'll focus on writes, right?
Yeah. Basically, in a previous episode, we kind of shown you how to create a command handler. In order to be more secure RS. So in order to follow secure RS, so the command query responsibility segregation, and we did kind of simplified version of this because, as you probably remember, we told that all the writes to our application are fully async. So we're using the RabbitMQ for publishing the particular commands, and then the commands get subscribed somewhere and processed. But for the simplicity's sake of that introduction, we kind of get rid of the whole QE, and we created we used the simple dispatcher for dispatching the messages called by internal API of the microservice. And today we're gonna make the full version of this. So we're actually using the, first we'll add the RabbitMQ as a preferred way of processing or maybe transporting the commands. And we need also some kind of facade between the end user and our whole infrastructure and whole services. So we'll also introduce the API gateway. And that's the plan for today.
Yeah.
Yep.
Okay. So before we begin, you need to have the RabbitMQ up and running. So as we shown in the first episode, you can go to this dnc DShop/compose directory, and here you can find a few files, and you need to run this infrastructure. So you can simply run it by typing docker compose -f, and then just infrastructure YAML full file name up and -d if you want to run it in dispatch mode. It will start RabbitMQ, Redis, and Mongo, which are the core services that you need to have up and running. Okay.
Yeah, and it's worth to mention that this is the RabbitMQ with the manager, so you can actually go to your web browser and go to the localhost.
Exactly.
And then 15672, I believe. And so you will see the dashboard of the RabbitMQ, and you can actually, even call or maybe send some messages directly through this using this the web dash.
Yeah, so it's localhost 15672. Default login is guest. You can just log in here, and you can browse through all of the connections, channels, exchanges, queues. You can check the messages. You can see the graphs. Pretty much do everything you want here through this web panel.
Yeah, I would say just one more thing. I would say that later on, if you'll have any issues with your subscriptions or something else, that's the first place you should actually visit, because maybe this web panel is pretty simple, so you'll easily see whether you're missing maybe some exchange is not running, maybe you're missing some queues, something is not actually fully set up. So this is the first place you should visit when you spot some issues with your asynchronous communication.
Yeah, exactly. Okay, so let's quickly check if our application still works. So I will just go to the repository where our CS proj resides. Let's try the .NET Run and see if our previously created post controller still gets the job done. So it should run my discount service, and we should be able again execute our post request. So let's see. Here is our discounts rest. let's try to send a request. It might take a while. Okay, it was accepted. So let's
Yay.
see if I open my database. It should be here. We have discount service. Yeah, and a simple single discount with our data in it. Okay, so it's working. And now let's get into our integration with RabbitMQ. Where should we start? That's a good question. We already have the command handler here, right? We created it in the previous episode, and we have our command. So right now what we need to do is to just subscribe to this particular message. So whenever we are talking about message broker, we are thinking in terms of either publishing or sending some messages to our broker, and then on the other hand, subscribing to the messages that we are interested in, right? So you can think of either events or commands that you can subscribe to, as well as events and commands that you can either send or publish.
Yeah. I mean, the RabbitMQ itself also supports other, maybe Rabbit itself supports other, I would say, mechanism of communication. So let's say the request response, but the publish subscribe, just fits into the CQRS. So we're just publishing the message. We're not looking for any kind of response or result from the handler.
Yeah,
so
only the basic ACK, so basic acknowledgement.
Yeah.
You can also.
But this is on the. I would say this is more on the infrastructure level. So
yes.
For the business logic or something, we're not actually waiting for any kind of response.
Yeah, I mean, in one of the next episodes, we'll show you how you can, for example, use this ACK coming from RabbitMQ in order to verify that your message has been published, and maybe retry it if it wasn't published or it was an error. So that's more like an infrastructural concern. Now, how to get started with our RabbitMQ? That's pretty straightforward because, as you can see, we have a lot of these extensions. So everything is here, so it lives in common. So within common, you can find this RabbitMQ. As you can imagine, we have this use RabbitMQ extension method here. Use RabbitMQ and add RabbitMQ for our IOC container. So let's try to use this one. I can put it anywhere, for example here, and I can just call builder at RabbitMQ like this. So that's the first thing I need to do. So it will just register all of our RabbitMQ interfaces, and there is quite a lot of stuff going on. We'll not go into like full details. We'll just talk briefly about some of these things under the hood, but let's just try to use this command. Use this method here, and let's try to subscribe to our commands that we're interested in, right? So I can type things like app use RabbitMQ. And here I can just leave it, but it will just start a connection. So it will connect to my RabbitMQ bus, and nothing will happen, right? Because I'm not subscribing to anything. But I can type dot, and we provided this Fluent API here where you can subscribe either to event or a command. I mean, this is just a message, so the message can be anything, but we wanted to have this separation, so it's either event or a command. Yeah, and we have our command already defined, so it lives here in our commands. So I can just put subscribe command and type of my command, and it's gonna be create discount. Like
and then there is a generic constraint on this subscribe command method. So this only accepts the types that actually implement this I command.
Yeah, we'll talk about events probably in the next episode. For now, we are just talking about commands. So as you can see, this is this interface. There is the Fluent API. So if I would like to subscribe to multiple events or multiple commands at once, I can just dot infinitely, okay? What else? Right now, I should be able to actually to connect to my RabbitMQ, but there's one more thing. I need to provide valid configuration. So we have this section called RabbitMQ by default, like this. And let me put there some configuration. I can go into any other repository. It can be API or order. So let's just see how it looks like. I'll copy this RabbitMQ section. As you can see, it's quite long, but except some of our custom fields, this is simply like an extension to the raw Rabbit library. So we are directly binding this this type into raw Rabbit library.
But the very basic, I would say that the very basic stuff is username, password, virtual host, host names.
Everything that starts here, it's the default stuff. This is our custom stuff. These 3 lines above. Yeah. So you can configure your your host names, your timeouts, your credentials, whether you want to have durable queues or queues that are being destroyed once your application is not connected anymore, and so on. You can do it here if you want, or through the C# code, whatever it's best for you. Okay, so right now when I start my app, I should be able to connect to my RabbitMQ just like that. So let's rerun it.
So to be clear, we subscribe to particular messages when the app actually starts, right? So the app subscribes on the very beginning of its lifetime.
Yes. Yes.
And it's not something like we dynamically add when we call some API. We just when it starts, we subscribe to a particular message, and this subscription lives together with the particular microservice.
Yeah, exactly.
Okay.
And as you can see, I already have my exchange for the discount service.
Yeah.
And of course, I have my connection, so I can see clearly in this web panel that my app is connected, and I should be able to actually publish here some messages. So the way the Rabbit works is pretty similar to other message brokers. So one application will be publishing messages. It can be our API publishing commands, or it can be our services publishing other commands or events. And this command goes to the RabbitMQ, to this so-called exchange. And then from this exchange, depending on the queue that is interested in this particular message type, which is defined by the routing key, it just creates a queue, and these messages that are currently living in this exchange and are being published to this exchange will be just pushed into these queues that are interested in these types of messages. So we're not going to get into like this theory behind RabbitMQ. You can browse it in the internet. There's a lot of great documentation here.
I would say that the one thing that might be kind of important here is that as far as I remember, the default behavior and maybe the default setup for the routing key in a raw Rabbit is the message of assembly.
That's correct.
Yeah, and that's the thing that actually had to be changed in order to support the messages that lives in 2 separated assemblies. And I think that's one of the
that's the important thing, because right now I have defined here my create discount command, right? So it lives in this namespace dedicated to this service, this discount service. And because we are not going to have any packages with our public contracts, instead,
as we used to, we used to have just one package that contained all type of messages. So the commands, events, and the queries that we'll talk about them later. But basically, we put everything into this contracts or messages package, and that was shared across API and all microservices. So each microservice could easily see whole contracts that we exchange between the services. And because of some we talked with some folks, and I would say the guys that were more experienced in this matter, and they suggested that we should actually split this, so each microservice should only contain the messages that actually are contained in the matter of the domain of the particular microservice, instead of having just one bulk bunch of contracts.
Yeah, you don't want to have any references to other services or packages. We only have this reference to our common package because this is all infrastructural stuff. But when we are talking about things like data, DTOs, or view models or messages, you don't want to have them because you can easily get into dependency hell. all these versions that may differ between different releases. This is going.
And
It can be helpful.
there was also one very cool. I would say the disadvantage of this of our old approach was that was the simply naming stuff. So it might be possible that two microservices, have, I would say, they encapsulate different parts of the domain, but they have some they use some common name. Let's say customer. So customer in one microservice, according to DDD, can mean something completely different in service A and completely different in service B. But let's say both of them need to create their own types of customers. So logically, because we know that comments need to be we have this naming convention, we would call this create customer. And now we have some collision of the names because we cannot create two create customer types, we could, but this might be confusing for other devs. So this is one of the things that actually was pretty tricky.
Yeah, just imagine you have the customer service as we have here, and for example, you have the support service or customer support service, and there might be event like customer updated. So it could be either produced by customer service or maybe by customer support service right now, and you wouldn't know which service produced it. You could get some ambiguity. So that's the reason why we at first don't have these packages, and why we have these separate routing keys. So basically, when you take a look at this message, we're only talking about the message name as part of the routing key. So we are not talking about namespace. Namespace doesn't matter for us at all. So this is like one part of the routing key, and another part is we just called it namespace because you can think of it as namespace. So as you can see here, I put this namespace called discounts, right? So right now, whatever gets published from my service, or I'm subscribing to this particular type create discount that lives within this discount service, I can say that's in the namespace discounts. So my routing key will look something like discounts dot create discount as its type name. All right.
Yes.
So we'll show you, for example, if you take a look at create order message that lives in another service, for example here, or create order rejected, you can see that we have this attribute message namespace. So right now, if I'm interested in a particular message that's not in my service that's actually publishing it, but for example, another service that wants to subscribe to this type of message, I will just copy and paste the same class, put the same structure, and then just add this annotation here that lives within this namespace. So it will just have this routing key properly resolved. So that's the whole magic behind. And if you want to look how it's being implemented, you can take a look here. In a raw Rabbit, you are able to override the naming conventions. So for example, here we are overriding the exchange naming convention or routing key convention when we are just taking this routing key namespace, which comes from this attribute or comes from this option if it's defined, and then it's just this attribute or option, and then the name of type as snake case. So that's the whole magic, and this is where it lives.
Yeah, so maybe to sum it up, because that might confuse lots of people. The default, the default
is the namespace.
Yeah, the default is the namespace plus the names, right? So namespace dot and the name of our type. So this worked for us when we had one package, because there was just one namespace, according to the particular type. But then we decided to split messages. So one particular command lives in a particular microservice. So as you see, message, commands, create, discount. And we will, in just a minute, we'll add also the same message to the API gateway, which has different namespace. So we had to get rid of this namespace routing key in order to actually make it work. So instead of namespace, we have I would say, the custom namespace, which is provided either in an attribute of the type or in a configuration.
Exactly. That's the whole magic. So you can dig into this code if you're interested how we map these routing keys. But it just works. It works just fine, and we can have different namespace with different types.
That's the best explanation. Yeah. So
forget
about the implementation. It just works like magic.
Yeah, but it took us some time to figure this out. So we are just glad that it works. All right. So right now, that's pretty much job done on my service side. I don't need to do anything else because once I have defined my subscribe command here, you can take a look that within this method, whenever I'm using this bus client coming from RowRabbit, so I'm subscribing to this type of message, and whenever this message comes from my service bus, I can execute here what I want to do with it. So simply, I will just use my service provider acting as a service locator. I will look for the command handler that is that is able to handle this command, and then I will just try to handle it. We'll talk about handling failures and retries in one of the next episodes, but for now you can see this is pretty much the same behavior as we had in our, for example, command dispatcher that we did in memory. The same thing, right? But right now our command comes from the queue, not from our memory or within the same process where our app lives currently. So the switch is very simple. We're only switching to different message provider, right? Nothing really else is happening here. So within our controller, we won't be using this method anymore, right? Because we will not be calling from our API gateway using HTTP client something like post async, then passing this create discount command as JSON and waiting synchronously for the response. That's not what we are going to do. We are not going to do this synchronous facade, which creates this thing called temporal coupling, which is what we want to reduce in our distributed application to make it more resilient and more responsive. So we can get rid of this one. We will not be using this anymore. Okay, so I think we should now jump into our API gateway, right? To create this whole flow. So today you will see how you can create your own gateway, meaning how you can write your custom code to make it work. In one of the next episodes, I will also show you how you can use my sample gateway using this library that I've been working on recently. But you can choose between different gateways. You can use Kong gateway, Nginx, or other services to define your gateways. There's a lot of options that you can use. But given that you want to have it implemented on your own, like we have in this API project, we just need to write some code. So you can browse through other controllers. You can see that, for example, we have some operations, some requests defined for orders controller, something like get or post, or for products controller, and all these things that we've shown you in the first episode where we've gone through this REST file, right? So we went through this REST file, through these endpoints, and all of this is defined here within these controllers, all of these operations. So let's create a new class, right? Or a new controller. I will call it a discounts controller. Oh, it didn't hang up this time. Maybe the latest update. It's a miracle. And
they did some major update after we published
it's
this
quite
on
cool
YouTube.
right now. Okay, so I will just derive from my base controller, and base controller is our custom class. So it sets up the core routing using the controller name by convention. It's using the API controller attribute, so we don't have to use, for example, from body when we are sending the data.
Additional attributes.
Finally. Yeah. And we are also saying that we want to have our JSON token authentication, but we can disable it for this demo. So let me just call this allow anonymous, so we won't have to deal with identity service for now to execute this request. And let me just implement missing members. Okay, so as you can see, we have iBus publisher. We are injecting it because our base controller provides this bus publisher, and as you may notice, or as you may think, we'll be using this bus publisher to actually send commands to our bus. So here below, you can see that we'll have here, there should be this send. Oh, here it is. There's this send async method. So what it does, it just creates some context. We'll talk about this context in the next episode as well, what it is. But it just is using this send async. So it just passes this command, which is our object coming to the API, and a context, and it gets published to the bus, and it returns the accepted 202 status code from our API. That's the whole magic.
Inside this send async, the whole magic happens. So actually creating this, as you see, use message context, but this is stuff that we'll talk later. And get routing key is the thing that we actually discussed. So this is creating this custom routing key using the namespace and the name of the type.
Yeah, that's the thing we talk about. Nothing fancy. Just raw rabbit, bus client, publish to the
so this class is simply some code that wraps the raw rabbit client. Nothing more.
Exactly. All right, so let's try to create our endpoint. So I can say that we'll have an action result. So since the latest version, not the latest, the 2.1 or 2.0, we can use these action results, which are either interfaces or are generic types, which can be helpful, especially if we are using Swagger. For now, I can just use maybe this generic interface, but later on we can also switch to action result of type T if you like to use Swagger for the auto documentation of our API. So let's call it a post. I'll mark it with post attribute. And
I don't know whether if you call this post, is this still required? I'm not quite sure.
No, it's not. It's not required, I think.
Yeah, I think that if you have get, I think that it detects by the naming convention if this contains get, delete.
It's either by the naming convention or simply by the routing that you can put here. So if I put here something like XYZ, and it will just look for this routing and apply this post, invoke this post method. And now the great question. Actually, we already have the answer. So where do I get this command from? So I can simply copy and paste this one. Okay. So here in our API we have these comments, and I will create a new directory here, and let's call it discounts. So I'll put there all of these messages that are related to our discount service, and I can create discount. So create discount command here, and I can just copy and paste it. And as we talked about it previously, really sometimes you need to get rid of don't repeat yourself principle, especially when you are working either with distributed applications, when you need to duplicate some data between services, or when you are working with DDD and you want to have the same concepts between different bounded context and so on. So try is a great principle, but it doesn't mean that you have to always apply it.
It's pretty much the same thing that I see that developers also tend to go way too far with reusable components. So at some point you actually try to create, as reusable application as possible, some kind of generic application that will solve actually any kind of domain will fit exactly in any specific domain.
Generic repositories, proxies, everything generic.
And so if you're not building the library or some framework for developers, simply don't do it, because you'll get into trouble sooner or later. And the same thing applies to this redundant code. So people tend to think that this is bad and only newbies do this, but when you try too much with using the same stuff, then it might also put you in trouble.
Exactly. And also the great thing about it is that, for example, here I can define this whole message objects, how it should look like. But for example, in my service, whether it's this service or some other service, if I'm using some flexible serialization, like for example JSON for my messages, I can maybe get rid of this one property, and it will be still valid message, because I might not be interested in the code here. But if I'm using JSON to serialize my messages, then it's all good, right? So it's also one of the advantages. And things like versioning or changing, removing some types that you're not interested in, you can do it simply by copying pasting the same structure and just changing some things.
Okay, so the only difference I see between this message and the message from the service is this attribute, right?
Yeah.
So by this we need to also pass this information that we actually want to hit discounts namespace.
So we said that our discounts messages will live in this namespace defined here.
Yeah.
And
the service itself knows this because that was provided in the settings, but API has no clue whether this message belongs to service A or B or C. API simply publishes this to RabbitMQ and has no clue whether actually this will be processed or which service will take care of this message.
So this is just a part of the routing key, and that's all. That's what we call namespace. All right, and now let's try to pass our create discount here, like this command, and let's see how is, for example, created here. So let's take a look. In my create order, when I want to invoke this create order, I'm just passing a command, and then I'm saying I want to send async using this helper method from our base controller. Okay, so let's get back here, and I can do the same thing. Let's say send async command. I can of course await it, and there is one thing that we need to do, because this is what we talked about previously, and it's all about our ID, right? So in order to bind my ID or to bind some other property, if I want to bind
we
it
can show
here,
it on a discount API, because that you still have this, I think, in a discount service.
Yeah, I think I have it. Let's see, discounts controller, right?
Yeah, but from the previous episode.
Oh yeah, it's
that's the same trick.
So that's what we're going to do here again, right? Because we don't want to map this command, rewrite it and all these things. So I'll just bind this like this. And we also have some additional attributes, arguments here. So I can say that my resource ID will be this command ID in order to return it from API as some helper header. And I can say that my resource path will be by default discounts. So later on, when we introduce our get methods for the API gateway, we'll be able to get our, for example, discounts list for this endpoint. But this is optional; you don't have to do it. You can simply do just this, and it should work. Okay, so I think we're good to go. Let's try to start our API and see if it works. By the way, we created a new branch called YouTube. So whatever we are going to publish, whether it's going to be API or some other service, which is not a discount service, we'll publish it to the YouTube branch. So by the time that we are recording this course, at least for this time, we won't be messing with our core master develop branches. So I can run it either through the script or by going to our src DShop API directory and executing .NET run. So let's start our script.
Yeah, that's more fancy way of running the.
Okay, it started, and we have our service. Do we need to restart it? I think we don't have to, because we subscribe to this message. All right, so let's try to execute the same commands as we did, but with a different URL. So let's put it 5,000, right? So right now, it will be sent to our API. Let's see, send request. And we should get 202 from our API. Okay, these are these custom headers. So you can get this information by using these arguments. But like I said, it's optional. You don't have to do it, at least for now. You should be able to see here. Yeah, as you can see, we got the message. So you can always take a look into this RabbitMQ web UI, and you can browse if there are any messages simply by looking at this graph. Right, or by going into this exchange, and by checking whether within this exchange there's been a message published.
Oh, can you get back? Oh, now you can see the routing key, that is discount.create discount.
Yeah,
so
this is
the name. How actually this is constructed.
Yeah. So this is the name of the service that is subscribing to this type of message. Here, like a full namespace and the the type of this message, so which is like our queue name, and there is the routing key, right? So we are subscribing to this create discount command. And let's see within our database if we have the data. So I should be able to just open it again. Yeah, and the data is here.
Yeah.
So it's working, right?
It lives, yeah.
Yeah. So what we did, like today,
maybe we can
Yep.
can we make another call, but with this time with breakpoints to be clear.
Oh
how
yeah, sure.
This actually works, because
yeah,
that
that
would
makes
be
sense.
helpful for.
So I will stop also for the API, or
Yeah, starting from the API.
all right. So let me create a new configuration here. I will call it debug, and I will create a new configuration, and it's going to be a compound. This is how you can create a configuration for multiple startup, for multiple services, multiple applications that start up at once for Rider. And I'll just call it API plus discounts, maybe like this. And here I will say I want to start my API, and I also want to start my discount service, but I need to add it as well because we don't have it yet. So I need to add discounts. Let's say discounts services.
Yeah, if you're using the Visual Studio, you simply need to open the solution, right click on the solution, and you will get immediately the multiple startup window, I believe.
Yeah.
It's kind of more simpler when it comes to Visual Studio.
Let's see, I have 5001, so it should be 5010 for this one. I'll just make it local and 5010 HTTP and apply, and then I'll just add it here as well. Okay, let's see if we can debug it actually. So it's been closed. It should start my API and the discount service, and let me put breakpoint here. So send async, one breakpoint here, and also maybe here, like this. I think I need to wait. Okay. And here.
Yeah. And in a, I don't know, maybe in a subscribe method extension method to see that this is actually.
Sorry, which one?
In a subscribe command.
Makes sense. So let's see if it's working already. So localhost 5000. Okay, API is not up and running yet. So let's go into our startup, and let's put the breakpoint here as well. So let's go to the definition, and I can put it here, for example, or maybe just here, or maybe here. Maybe that will be even better.
Is a good one.
Okay.
Okay, the API is running, and the last one maybe in a command handler, just to see that.
Oh yeah, that makes sense. So let's go here, and let's put it here.
I think that's
some nice colors from my sorry, look.
Yeah, it's even more.
5000 and 5010, and okay, we have our services up and running. And let me execute a request again through the Visual Studio REST client extension. I'll just call it promo maybe 2, and let's send a request. Okay, it's waiting. And okay, so our request hits the API. As you can see, we have our data bound from our REST client. ID is for now empty, but it will be assigned for this extension method. So I can click F5, and here already we have our commands with assigned ID to some random GUID. All the data is here. And
so we're simply we're simply publishing this with this context object that we're not discussing.
And the message will be here in our exchange, okay? And now we hit our bus subscriber. So as you can see, there is a command incoming, right? And I can click F5, and it should resolve my create discount handler because we received the command of type create discount.
So it works the same way that that Piotr said. So it is just dispatching the message using the. In this particular case, we don't use the dispatcher for the commands, but we simply use the simply dependency injection.
Yeah.
So simply get me the object that actually implements iCommand handler interface. So in this case, this is the create discount command handler.
Exactly. And now we are in our command handler, and that's pretty the whole magic. Like nothing to do in terms of our commands or handlers, maybe except defining the namespace, which is part of our routing key, which is our custom convention. But besides, the switch was pretty much no-brainer. So if I want to, I can still use this method and test it in memory without service bus. But if I want to use service bus, I can just subscribe to the particular messages here and define my handlers, and nothing else I need to do. So my data is here. I can check it in order to be sure, and that's pretty much it. So I think that's all for this episode.
We actually achieved the half of the CQRS at this point. So we actually are fully asynchronous in the matter of writing to our application, and that's what we actually wanted to achieve. So this is the preferred way of doing the writes when it comes to microservices.
Yeah, I mean there are still some companies or some projects that don't put these commands into the queues. They just send for example through the HTTP client message to internal API of a particular microservice, and it's still valid. And it gives you some benefits because you're getting synchronous response. So there is no things like eventual consistency and so on. So it may be better for the end user. But if you want to achieve like a real scalability, responsiveness of your API, you need to go like fully asynchronous. And using some message bus, it's one of way how you can do it. So yeah.
But you will see that this change actually implies a lot of I would say that disadvantages that you need to take care of.
Yeah,
but we'll discuss it for later.
Yeah,
in this tutorial.
This is where all the fun part starts with this asynchronous commands and messages, and a lot of things that you probably didn't even think of could happen are going to happen.
At this point, you think, "Damn, I'm pro. I can, create the CQRS. I'm maybe not the CQRS, but I can make the writes in my application fully asynchronously." And later on, you actually think about backup. We need to back up to monolith because this makes no sense.
Yeah,
it's way too hard to maintain.
And before you rush to tomorrow or the next week and tell your boss you should rewrite everything into microservices, just hold on for at least a few more episodes, because it's not as simple as it looks like at this episode. There is a lot of things going on that you need to take care of. But
the fun part is coming.
Yeah. So that's pretty much for today, and stay tuned for the next episode. It will get much more interesting with each next episode. So thank you, and that's all for now. See you.
Bye.